In this chapter, we're going to learn about sequences. We've had some experience with sequences in the form of strings, and we've seen loops, or rather lists earlier, but we haven't really gone into detail about them. We've kind of just mentioned, we'll handle it later. Well, later is now, and it's time to get start with them. Now, the big difference is with sequences and other data types, which we might refer to as atomic data types, like integers and floats, and booleans, is that integers and floats, they just hold one thing, right? They store one piece of information. But a lot of times, data isn't stored in just by itself. It's related to a bunch of other data. For instance, you might have a list of all the things that you might want to pick up when you're at the grocery store, or all the things in your shopping cart on Amazon, right? So, similarly, we generally don't read by looking at one letter at a time. We look at the whole word and read it that way. So there are three types of sequences we will be learning about, and they all use a lot of the same syntax to manipulate them with their indices and their slices. So that's why we introduce them pretty much all at the same time. Two we'll use pretty often, strings and lists, and the third type, tuple, we're just going to touch on, but we aren't going to use it that much. So let's talk about the first type, which is a string. Right? We've seen strings. Strings are a collection of characters or glyphs. So here we've got S is equal to this is a string. And, this is a collection of a bunch of characters. The smallest string possible is the empty string, which just simply means there's no letters in there. We can see that it has a length of 0. Remember, length, you can just throw any sequence in it and find out how big it is. So, length so let's give it a literal over here. Length of hello is equal to 5. Alright, so our next thing is a list. Now, lists are one of the most useful things. Lists are just ordered collections of data. In other words, we care about the order that things are in. Although the data could be unordered, but it's stored in an ordered fashion. There's a first thing in a list, and then there's a last thing in the list, and they're not really going to change without you manually going in and changing it. So let's make a shopping list. I'll just call it L, like I was doing. L, apple, banana. The problem with spelling banana is not knowing how to spell it, but know when to stop spelling it. Alright. Let's go with carrot over here. And, of course, the king of fruits, the durian. Apple, banana, carrot, durian. Alright, so here we have a list of strings. Right? Lists can hold anything, including lists of lists. And while that sounds horrific and complicated, you deal with lists of lists all the time when you create outlines, right? Whereas all the sections and their titles are one list, and each section has stuff within it, right? They have subsections and like, so it's not too much different than that. The hardest part about it is visualizing it, which I'll give you some aid about when we deal with lists of lists. But for the most part, in Python, we can just deal with lists of stuff. In Python also, it doesn't really care. You can mix and match. You can put in a number and a number. And again, the length of this is 2 because there's 2 items in it. Right? And also, the length of this guy is 4. Whoops. That's what happens when I try to type and talk at the same time. not because that's the number of items in it. Okay? So what you should know is that you can change a list. You can change a list. L.append, and we'll go into more detail about these later. L.append eggplant, just to keep with our ordered theme here. And now we see that we've added eggplant to this. So you can add to a list, you can change it, and that's perfectly fine. But strings are what we call immutable, meaning they cannot be changed, right? So we have s, the empty string. You cannot, if we say s is equal to, now I mean we can do something like this. S is equal to s plus apple, and we print out s, and it's apple. But really what we've done is that we've created a new string. We've taken s and apple. So we've taken the empty string, added apple to it, which resulted in apple, and we've stored the resulting string in s. But there's no way to update a string itself, as you'll see. The final type that we are going to be dealing with is tuples, which we don't really deal with too much, though. And that's perfectly fine. Well, tuples are very, very similar to lists. They're just like lists. They're just comma-separated values. So here, right, we've got info is equal to, except here instead of using brackets, I'm going to be using parentheses. Info is equal to Andrew Rosen, right, and that's it. The big thing about this is that a tuple, just like a string, is immutable, so you can't change those things like you can with a list. So then you've got three types. You've got your string, you've got your list, and you've got your tuple. Lists and tuples are pretty much the same thing, but you can change stuff inside a list. You can't change stuff inside a tuple. And you can't change strings. We'll get into we'll deal with that later. But the big thing here is that we are going to be using lists and strings a whole lot as opposed to tuples, which we won't use so much, and we'll mention them. So when they come up, you'll go like, right, tuple, I remember that. You've mentioned that a time or two.